Hey y'all. Today's objective is rational and irrational numbers. So in the number system, we have rational, irrational, and those all form the real numbers. So you notice I have real numbers. So we're talking about real numbers. There is such thing as imaginary numbers, but we're not addressing that today. Real numbers are broken up into two categories. We have rational and irrational. We're going to talk about rational numbers. In the easiest, most simplistic form, we have counting numbers. And when you count, you start with 1. So counting numbers starting with 1, 2, 3, 4, and so forth. Then you have whole numbers. Whole numbers include all the counting numbers and 0. So whole numbers start at 0 and then the counting numbers. Integers include whole numbers and counting numbers, and the only thing that's added to integers are the negatives. So -3, -2, -1, 0, and then all the positives. So an integer is a positive or negative whole number. An integer means no decimal, no fraction. So those are kind of the three: counting number, whole number, integer. Sometimes the word counting number is replaced with natural number. Because even babies, when you start to count, the first thing you learn is 1, 2, 3, and then it takes a little while for you to understand 0. If it doesn't fit into these categories, if it's a fraction, a decimal, maybe a repeating decimal. If it's a fraction, decimal, repeating decimal, or terminating decimal, those are all rational numbers. They do not fit in counting whole or integer, but they are rational. Anything else is going to be irrational. So over here we have pi is irrational, and the square root of non-perfect squares. The square root of non-perfect squares. So I'm just going to write non-perfect squares. The square root of non-perfect squares. Non-terminating and non-repeating, non-repeating decimals. And those are irrational. So if it's a decimal that repeats, it is rational. If it doesn't repeat, if it doesn't end, then it's irrational. So we have rational and irrational, the two different types of numbers in the real numbers. Okay. I'm dropping my boards. Sorry. All right, copy this down. Example number 1, classify as rational or irrational. So we're going to look at that chart that I just showed you, rational or irrational, and does it fall into the rational or irrational? So 3/4 is a fraction, so that would be rational. 1/11 is a fraction, so that would be rational. It's a fraction, but it's still rational. Now the square root of 3, this is a non-perfect square, so that means this would be irrational. It's a non-perfect square, so it would be irrational. D, we have a fraction underneath the radical, so we need to evaluate this to see if it's rational or irrational. Can you take the square root of 1/9? You can. Take the square root of 1 and the square root of 9, which would be plus or minus 1/3, because the square root of 9 is plus or minus 3. Now I'm back to a fraction, so that means this value is rational because it's just a regular fraction. The square root of 1/10, the square root of 1 is 1, but the square root of 10 is a non-perfect square. Therefore, if you type this in your calculator, it would be non-repeating and non-ending. So that makes this an irrational value. Now, the square root of 99. 9 is a perfect square, but 99 is not a perfect square. So since this is the square root of a non-perfect square, that means it's irrational. You try this one. Negative square root of 25 is -5, so this would be a rational number because it's the square root, a perfect square. So it's actually an integer, which is a rational number. All right. Time for example 2. Copy these down. Pause and copy it down. Graph the numbers on the number line, then compare less than, greater than, or equal to. So I have two numbers, the square root of 1/2 and 1/2. Now I know that 1/2 is 0.5. So on my number line, since this is 0.5, I'm going to start at 0, 1, and 2. I don't know what the square root of 1/2 is. I'm going to use my calculator in a moment. So 1/2 is right here, 1/2. Then, hold on, I forgot my calculator. All right, you're going to be able to use your calculator. The square root of 1/2 is approximately about 0.71. It's about, I'm using my calculator, 0.71, which is going to be between 1/2 over here. And now that I've graphed them both on my number line, now notice I didn't use my decimals. I used the original numbers to show on my number line. So I can compare them. The square root of 1/2 is greater than 1/2. The square root of 1/2 is greater than 1/2 because it's farther right on the number line. All right, let me show you this one right here. We have 4/5, which is 0.8. And the square root of 4/5 is 0.89. Now, I'm just going between 0 and 1 because both my numbers are 0.8. I don't need to go all the way. Actually, we're just going to go from 0.8 to 0.9 because I don't need all those others. I'm just going between 0.8, which is right here, and 0.89 would be like right close to 9 over here. So 4/5 and the square root of 4/5. So now we need to compare them. So 4/5 is less than the square root of 4/5. 4/5 is less than the square root of 4/5. All right, get those down. All right. Example 3. We are going to use the calculator. So I'm going to first estimate the square root of 1.7. And the square root of 1.7 is about 1.3. Now everything else is written as a decimal, so I can order from least to greatest. I have 1.3 and I have 1.3 repeating. This would be 1.33. And this one would be 1.30. So sometimes you need to go out into the hundredths place so you can accurately compare them. 1.30 would be first, and then 1.3 repeating. Next, 1.7, and then 1.89. So ordering from least to greatest, first you want to estimate any square roots that you have using your calculator. Go out to the tenths or hundredths, maybe even the thousandths place. Then you can order your numbers. All right, example 4 is a word problem that I'm going to put right here. No, you do not have to copy the word problem down, but you want to get the formulas right here. I know it's, all right, for large, I'm going to read it because it's going to be typed right here. For large ocean waves, the wind speed S in knots and the height of the waves H in feet are related by this equation. So the wind speed and the height. If the waves are 9 feet tall, so this is how tall the waves are. If the waves are about 9.5 feet tall, what must the wind speed be? And here's a little thing. 1 knot. Remember it. 1 knot is about 1.15 miles per hour. So if the height is 9.5 feet, that's how tall the wave is, then what does the speed have to do? You need to substitute it into the height, which I've shown you. And then depending on your calculator, you can type that whole thing in, or you want to break it into parts and type in 9.5 divided by 0.019, which is 500. And then the square root of 500 is about 22.36 or 22.4 knots. 22.4 knots. That means 24.4 knots is the speed, the wind speed, if the waves get that high. So that's how they can tell how fast the wind is blowing, determined by how high the waves are in the ocean. All right, last examples. Copy this down. Evaluate when A, B, and C equal 2, 4, and 9. Classify as rational and irrational. So first we have to substitute. B is 4. C is 9. And we multiply. We add all of those, and when you add all of those, you get 49, and we can take a square root of 49, so plus or minus 7. The square root of 49 is positive or negative 7, so I've evaluated it. You substituted in, and then you solve it. All right, B, same type of thing. We're going to substitute our numbers in. I'm going to multiply everything out. Now 2 squared is 4. I'm going to add and then subtract from left to right. So that is 44 minus 4 is 40. The square root of 40, this is an irrational. Whoops, I forgot to say, this is rational. Sorry. This is an irrational number, and it says round to nearest tenth. So the square root of 40, we could show, or we've already learned how to estimate to the nearest tenth without a calculator, but for our purposes of time, 6.3 would be about your answer, about 6.3. And the number is irrational because it's not a perfect square. All right, we're going to practice some more with rational and irrational numbers in class.